Ahoy and welcome. My name is still Clemens Helm, and you're watching Codeship Testing Tuesday number 7. As I promised you last week, today we're gonna take a look at managing test data. By test data, I mean data required by your tests. Especially integration tests usually require a specific test data configuration to perform on. By the way, what's an integration test? Integration tests test multiple components of your web application at once. So they might test your user interface, your whole web application, and your database. Whereas unit tests only test single components, so maybe a model or a controller. We're going to take a look at this difference in next week's episode. But for now, let's focus on how to create test data for our tests. One possibility is to simply insert it into the database before running the tests using SQL like this. What's wrong about this? Most of all, it's not readable. You need to read a lot of unnecessary SQL syntax to figure out what this data even means. A better option is to use a structured data file like YAML. These structured datasets are called test fixtures. They're more readable and you can easily parse this data and insert it into the database. Also, this way you're not depending on a specific database type and can migrate your tests easily to something like MongoDB later on. So what we can do now is insert all our test data into the database first and then run our tests on it, right? Wrong. Most of the time we modify test data during the tests. That means the next test has to deal with modified test data. That's not what we want. We want each test to run on fresh, unmodified data. So we can simply regenerate all test data before each test, right? Well, you could do that, but then you generate all data for any test for each test. As your test suite grows linearly, the time for setting up your test data will increase exponentially, and that's definitely not what you want. Instead, we actually only want test data that's relevant in a test. So in your test, you could do something like Bob is load fixture Bob. But then, why do we need fixtures anyway? We could just create test data in each test. We could say something like user new Bob and copy this stuff in. Well, fixtures are much more maintainable. Let's say you've got 200 tests using some users. And then you add a required attribute secret wish. Then you had to walk through all your steps and add secret wish here. You need to correct your test data in all 200 places. If you stick with just loading the fixture Bob, then all you need to do is add the secret wish up here. So when your application changes, instead of correcting the test data everywhere, you just have to correct the fixtures. Unfortunately, as your project grows, you usually need a large number of fixtures. You may need old and young, female and male, dead and alive users, and combinations thereof. Also, maybe you have to define 20 attributes for each user, so it's a valid record. But you only need one specific attribute for your test. This way you will end up with a huge amount of, mostly duplicate, fixture data. This will of course lead to the same problem. Test data becomes hard to maintain. There is a number of tools that solve this problem. My favorite one is Factory Girl. Factory Girl is a fixture replacement written in Ruby, but there are also similar implementations in Python, PHP, Scala, and JavaScript. Check out the further reading section to find out more. In Factory Girl in Ruby, we define factories like this. So the format looks quite similar to our fixtures before. Now we can create a new user in a database by saying Factory Girl create user. So we can see it inserted into the database. If you just need the user without inserting it into the database, you can just say Factory Girl build user. And there is a user that's not saved in the database. We can also override the attributes defined in a factory when we're building a user. So we could say name Clemens Helm. And all the other attributes stay exactly the same as they are defined in the factory. We can also tell a factory to generate a different attribute for every new object. Let's say we only allow users to sign up once per email address. Then we could just add a sequence here, generating a different email address for every new user. So when we create a user now, we can see it has email user1@example.com. When we create the next user, we can see it's user2@example.com. So there's going to be a unique email address every time. One of the most beneficial features of Factory Girl is that factories can inherit from other factories. So one good strategy is to keep all required attributes in a factory and let all other factories inherit from it. So you just need to define required attributes once instead of for every single factory. Let's say our secret attributes are optional. Then we can define a factory inside of the user factory named user with secret. And in here we can insert the secret question and the secret answer. This comes in really handy for different user types. Let's say we have a second type called old user, which has a year of birth in 1931. And now we can use these factories as well. We can just say Bob is factory girl, create user with secret, and grandpa is factory girl, create old user. And as you can see, they share the required attributes like the name, but Bob has a secret question and grandpa has a year of birth. This helps clean up our test data massively. There are many other neat features Factory Girl has to offer, and there are many other excellent tools for managing your test data as well. I can highly encourage you to check them out. I hope you had a great time watching this episode. Next week we're going to talk about integration and unit testing and how to use it with behavior-driven development. So thanks for watching, see you next Testing Tuesday, and don't forget, always stay shipping.